Good morning, everyone, and welcome to this new free X-Rite webinar. The topic of today is the M standards. If you have any questions during the presentation, please feel free to write it in the proper chat panel on the right-hand side. At the end, we're going to read all your questions to Rabea. The session is recorded and is going to be available starting from tomorrow on our Vimeo and YouTube channel. Thanks for joining us, and we are sorry for the little delay. And now let Rabea start the presentation. Thank you so much.
Good morning, everyone. Yeah, today we will talk about the new ISO measurement standards, the M factors, and how it affects your business. My name is Rabea Peisen, and I'm the application specialist for X-Rite in Germany. Market researchers make it clear 70% of the consumers' buying decisions are made at the shelf, and typically you only need 7 seconds to make a decision in front of the shelf. Typically, you also cannot really say why you made a decision for the one or the other product. That's always popping up with WebEx. I don't know. You can't do it up front, unfortunately. So 80% cannot really tell why you make the buying decision. And probably the color has probably over 65%. So the driving decisions involves color as well. I mean, if you have a product on the shelf that looks a little bit washed out, you would probably choose the one that looks a little bit more punchier because you expect it to be not explored to the sun for longer or something. So 60% of which of color accounts in acceptance or rejection. As I said, if you have a product that looks washed out, you think it has been stored in the sun for quite some time. So color and color accuracy and color matching between products of the same brand is very important. So there is no room for any error. The ISO standards have a big impact on that one. And there are a couple of standards that all work together pretty well. First of all, you need to make sure that you need to have your viewing conditions properly aligned. So D50 is the typical European norm light standard for viewing booths. This ISO standard 3664 has been revised in 2009, and we will come to this difference in a minute. But this has this all works together also with the spectral measurement and colorimetric computation for graphic arts images, as it's called. And these are basically the measurement standards. And these have been revised to exactly the same time, and they are now called the M standard, so the measurement factors. Also, the ISO 5 series have been changed in 2009. That's all about densitometry. Because all of these conditions have changed, the ISO also revised their process control standards because they are linked very, very deeply into this 13655 spectral measurement standards. Because previously, the old ISO norm was based on polarization and non-polarization data, and now the new process control series needs to take the new measurement conditions into account as well, and also for the viewing condition. So all of these standards, all of these norms are working very closely together, and you always have to make sure that you combine them in the proper way, and this is where we will talk about today. The problem actually starts with making products look better. So why do we need to talk about these M standards and the new bulbs at all? The reason being that we are more and more using optical brightening agents in our papers and substrates. There are fluorescent brightening agents or fluorescent whitening agents. Generally, the overall term is OBA. The enhancements of the appearance of color for papers using a whitening effect. So there are different methods, different possibilities to do so, but in general, they all try to make a rubbish paper looking better. Not really a rubbish paper, but they're trying to make paper looking even brighter than it actually is. This can be found not only in paper, can also be found in plastics. It can be found in inks, toners, and textiles as well. So it's not only unique to our printing industry. Yeah. When you have paper with different with different OBA contents, you would not necessarily see it under every light that there is a difference. So different lighting creates different results. Here we have a typical household lighting, a tungsten lighting, with a typical norm light booth filled with typical products that can be under the in the booths of our customers. When you look at it under a retail store light, which is typically slightly warmer, but still not really a high amount of UV in it, it looks different, but you don't really see a big difference in the sheets in front. As soon as you approach daylight, you can see it starts that the right-hand area of this white sheet is actually looking slightly brighter compared to the others. That's actually 4 sheets. And when you show the next image here, you see that when you just look under UV only, you immediately see that you have 4 different sheets in front of 4 different sheets of paper in front. And starting from the outside, the UV, the optical, the OBA, the optical brightening agents, increases to the right. And also you have some textiles in the back where optical brightening agents are used, or fluorescent substrates, fluorescent inks. You never really know just by looking at it. So different lights create different results. So if you use the D50 norm light bulb, you already see a difference between the colors of the paper shades, although they are all white. Yeah, optical brightening agents create these color measurement challenges, which we have to get under control. So with different measurement devices, a different look also means different data. So same as underneath the norm light bulbs, when you see already on the D50 lighting, you see different results between different papers. Your devices, your measurement devices, will also see differences depending on the light source used in the devices. Previously, all these standards for viewing conditions and for measuring conditions haven't really addressed that problem with OBAs because it wasn't really in use. And it was never really standardized clearly how much UV should be part of the D50 lighting content. So neither for the viewing condition nor for the measuring condition. So, and therefore, if you have a norm light bulb with a high UV content, and a measurement device on the mode UV cut, then you would probably don't see exactly, then your device doesn't see exactly what you see, and this is a conflict. So your norm light bulb has a high UV content in it, your device doesn't, then you don't see the same results as the device. And that's the reason why this ISO standards 13655, 3664 and the ISO 5 series have been revised to address exactly this issue. So the 13655 defines now the new standard illumination models for instruments and M, which is the M standard. The norm light bulbs, D50, have been revised now as well to agree on a certain amount of UV content in its light source. And this is what the ISO 13655 now does as well for the measurement conditions. So with this new revised ISO standard, we have now 4 different measurement conditions to address different applications. the M0, which is the historical condition, no filter, the new M1 daylight D50 filter, which is now correctly defined how much UV content it should be in it. The M2 is the old UV cut or UV non-UV filter, different names for the same thing. So the UV cut filter. And M3 is the polarization filter, as you knew them already for density measurement in the ISO standard. So before you exchange data with your customer or with your supplier, make sure that you agree on the condition, on the method you are measuring. This is how different substrates will look under different lighting conditions. Yeah. Now we have materials with no optical brightness measured in M0, which is our previous measurement condition, in M2, which is UV excluded or UV cut, and the new D50 illuminant M1. You see here the reflectance of paper with no optical brightness in these three measurement modes give you exactly the same result. So if you don't have any substrate with optical brightness, you wouldn't see any difference between M0, M1, and M2. Neither would you see any difference in your norm light booth between the old bulbs, according to the old standard, and the new bulbs with the now better defined UV content in it. But if you're using paper with optical brightness, then you would see immediately a difference. The UV cut, let's start with the green line, the UV cut measurement will look quite similar than it was before, because it will cut every UV content of it. But the previous M0 and now the new D50 illuminants will show you a higher peak in the area of 420, 440 nanometers, which is the blue. So why can it give you more than 100% of reflectance back? Well, the answer is it's physical. It's in the OBA agents, in the optical brightening agents in the substrate, which reflect light from a different area. So the UV content of the D50 and of the M0 condition emit light in an area where it is below 400 nanometers, so in the UV area, and this light will emit in this area around 440. So it's a chemical physical reaction that makes this substrate and that makes these agents behave like that. So the paper gets a little bit bluer touch, and that makes it look brighter than a typical yellowish shaded paper. So let's have a look into the different modes separately. The M0 is the previous measurement condition. The majority of all spectrophotometers are using these in the graphic arts. And the lamp which is used inside this device is basically an illuminant A, and the calculation of the light that hits the substrate and the light that comes back can really define exactly D50 as well. It can define a D50 illuminant in calculation as well. But the UV content was never really completely defined. It's commonly in use, it's a practical workflow, but whenever you are using substrates with fluorescent, and especially if you have already changed your viewing booth bulbs to the new ISO 3664, then you will see a difference in what you see and what you measure. So the substrate will look more bluer visually than what your device measures. Typically, this B value is the one which you're looking into when you check your LAB content. So if you don't have any instruments that meet M1, so if you only use your old M0 devices, then at least try to use the instruments of the same manufacturer and model. Then you would at least get a consistency in the results of the device. But if you already have your new viewing booth bulbs in there, in your viewing booth, then you will see the paper much bluer than your device actually measures. M0 is the measurement device that will cover this problematic thing here. M0 has the UV content of D50 defined exactly in the same way as the norm light bulb. So it's now exactly clear how much UV need to be part of this D50 light source. And in the X-Rite Exact, this is realized with a D50 filter and an additional UV LED to make sure that you have in your light source of the device that you have a UV content in it. And then the filter does the rest and makes the calculation or makes the filtering of the exact D50 spectrum. This M0 definition, or this M0 definition, comes with two different parts. So there are two ways of approaching this. The X-Rite Exact, as we've already said, is using a filter and a UV LED. And so within one measurement, you have the result. This is defined in M0, in M1 Part 1. M1 Part 2 also allows the compensation of the UV content according to D50 in the illumins used to measure the sample. So in the X-Rite i1 Pro, this is realized, for example, with a dual reading. So you measure once with the tungsten lamp, and then you measure at the second time with the UV LED, which is also part of the i1 Pro 2, and the software calculates the result. The difference between M1 Part 1 and M1 Part 2 is that only with M1 Part 1 you can also measure fluorescent colorants and not only substrates with UVA. With M1 Part 2, this is not usable fluorescent colors. It just covers the measurement of the OBA enhanced papers. Because if you really want to measure fluorescent, then you have to measure that. Then you can't just calculate the results. You have to get the light source to emit exactly D50 in the first place. So two parts of the standards for two possible methods in the devices. You also have to think about the capability of the two devices. I mean, the Exact is a bigger press room device where you have the possibility to make a filter and put it all together into this little bit bigger product, while the i1 Pro 2 is just a small device where you basically do the calculation inside the software. So that's just something you have to keep in mind. If you really want to not only measure substrates with OBA, but also fluorescent colorants, then the X-Rite Exact is the device that covers that. Both M1 methods match to the ISO 3664 viewing standards. So you can really measure as you see. So the difference you see between papers with OBA contents underneath your viewing booth is something you should also see in the measurement results of the device. And it also allows a closer relation between the devices from different manufacturers, because it is now a much clearer and much more tighter definition that devices from different manufacturers are more comparable to each other when using the M1 standard. The question you always have to ask yourself is, does your viewing booth conform to ISO 3664? And whether your observations in the booth with the OBA paper also shown in the measurement data. If this is not the case, then there is either the viewing condition or the measurement condition in the wrong mode. So always try to tighten it together and make sure that the viewing conditions are matching your measurement conditions. M2 defines the UV exclusion. Well, this is what we already had in SpectroEyes and also the i1 Pro had a special i1 version with UV cut, for example. And this basically specifies the behavior of the measurement where there is no UV content in at all. So when there is no UV content in the light source, there is no OBA emitting within the bluish area, so the paper will look as yellow as the other paper without an optical brightening agent. This filter is also known as UV cut, no UV or UV filter. There are several names for the same thing. And it also provides a test for instrument compliance, because if there is no UV content in it, the rest is quite the same as before, as in the other measurement mode. And it defines a way for instrument manufacturers to provide agreement that do not provide UV at the measurement plane. So it's the possibility also to compare results between manufacturers. A matching viewing condition, as I've told you before, always make sure that your viewing condition match your measurement condition. If you want to see what you measure when you measure without UV cut, you basically also you can make a UV cut filter underneath your viewing booth as well. So it's like a foil which you can put underneath your norm light bulbs. Last but not least, we have the M3 polarization filter, the M3 mode with polarization. You know that within the old ISO standards, polarization has been used for densitometry readings, while spectral data was without filter. This reduces or minimizes the reflections. And it also allows the color comparison between wet and dry inks or smooth and rough surfaces. As this polarization also removes UV, it's basically a UV cut plus polarization, and it's typically achieved by full polarization function or a filter. Attention, there is no viewing condition that matches these measurement conditions. So you can't really simulate what you measure with a polarization filter. In the end, you're making peaches look like nectarines, yeah, or vice versa in the end. So you have a rough surface of a nectarine and the smooth surface of the rough surface of the peach and the smooth surface of the nectarine, and you just want to measure this color, then polarization filter is what you can use. But as you see, when you just look at it on the viewing condition, they will look different because of the rough and the smooth surface. But if you just want to capture the color, polarization filter is what you can use. Little overview, the typical use cases for the different methods. To measure the effect of OBAs, you need to have an M1 part 1 or part 2 device. If you want to measure ink fluorescence, you need to have M1 part 1 devices like an X-Acto. If you just want to measure non-OBA stock, you can choose either of these measurements. If you want to cut the effect of OBAs, then you need to have either M2 UV cut or polarization filter in use. If you want to cut the first surface reflections, then the polarization filter is the condition of choice or the method of choice. And as always, agree on the standard to use in exchanging data before measurement. So if you agree on the standards, you shouldn't get any problems. So why is this M0 and M1 discussion still not so well known in the industry? It's from 2009, we're already 2014. What has happened in the last years? Well, the printing industry standards have been established with the M0 condition, and it's a de facto standard and it's working. So it's the only problem exists as soon as you're using substrates and with OBAs in combination with the new norm light bulbs. So now you're driving the attention to the problem. And this also will drive the adoption rate of M1. At the moment, the FOGRA is carrying out print tests for the practical workflow of the new ISO 12647-2 for offset printing 2013 printing standards. And these are the new standards that will be measured in M1. and also assessed underneath the new viewing conditions. And because of that practical tests, the next step will already probably have crossed your door as well. There is a huge problem with proofing paper, because proofing paper typically in historical doesn't have optical brightening agents, because these are not long life stable enough, and that's why it has never been used in proofing paper. So how do you want to simulate a result on an optical brightened high bright white paper on a proofing paper that cannot achieve that brightness because of its not having optical brightening agent in it? So at the moment there are tests as well of the usage of optical brightened proofing paper as well. Otherwise you will not have a possibility to compare a proof with a print result. So that's just the theory. Let's have a look what tools we can offer from X-Rite for these measurement conditions. We have on the one hand the X-Rite Exact for the press room, and on the other hand we have the i1 Pro 2 for pre-media. The i1 Pro 2 is already quite an established device. You might have already seen the new one. It's, I think, now on the market in 3 years, I think. And it's replaced the previous i1 Pro, which was the little gray instrument. Now it is an aluminium case, and it has multiple measurement conditions in one. So previously you had to choose between i1 Pro UV cut or i1 Pro. Now you have M0, M1, and M2 all together in one device. And this is realized through a dual illuminant optical design. As I said before, you have the typical tungsten spectrum plus an additional UV LED, and you basically measure twice, and the software calculates M1 and M2 based on your measurements. It also has a self-check and autocorrect functionality with the additional white patch that comes along with it. So for small instrument shifts, there is a little new wavelength calibration technology that brings the device always back into square. It also comes along with a new ruler, and as you see here, it has a little zebra strip on it, and the device has a sensor that recognizes exactly the position. So together with the color difference and the position detector, you can have now smaller patches because the software always knows where your device is. So you can use smaller patches, and the new ruler also have an improved floating guide rail, and it's solvent resistant as well. We also improved the usability with some LED indicators. So when you do your measurements, it indicates in what direction you have to measure, whether it was okay or whether something has failed by using red or green indications. And that helps you when doing a measurement of a big patch. You don't even need to look onto the software to know where you have to go, because the device indicates it to you. And last but not least, this was also something a couple of users have complained about. The optics protection was always difficult to clean because it was just this little small opening, and dust could easily be captured in it. Now you can we have made the lens or the protection, the little glass window detachable, so you can clean it better. Just these little things and a couple of more we have improved in this device as well. The X-Rite Exact is the best solution when you are on the press room and you want to make process control, or when you are in the ink kitchen to do ink formulation. It's robust and modern device, similar look and feel like the i1 Pro 2. It has an aluminium case, aluminium housing. Even the display is easy to clean. It has USB and Bluetooth connection, and it comes with a separate docking station where it can be put into while in a quiet mode, And if you leave it open like that, it automatically calibrates because it has an integrated wire tile, which you can see here. It folds away when you measure, but when you leave it open in this position, it can always calibrate itself in the time frame that the device has in its definition. And it obviously protects the optics from dust as well, because in the closed environment, it will always cover the optics, so it can calibrate and protects at the same time. Just leave it open. The display is a touch and swipe display, which you should be, well, it's meanwhile quite simple. It's quite similar to smartphones, so in its intuitive user interface, you can configure tools individually for different users, for different applications. You can also define different user groups so that you can give the printer exactly the tool he needs and don't give him too much stuff where he can be confused with. It comes with well-known functions and also expanded functions like best match, ISO, jobs with pass and fail, Pantone libraries for sure. We have added some trend graphics, and you can see the spectral curve now on the display, TVI overview, a lot of goodies that comes along with, and it utilizes the latest spectral technology. It comes with all M standards, obviously XRGA conform. M0, M2, and M3 will be measured in one go in underneath 1 second, so it's a really quick device. Only for M1 you have to swap the lever on the device to swap the D50 filter into the optics. So M0 is a separate measurement, but it's just one measurement to capture M0 and not two like in the i1 Pro 2. And it comes with software, and it's attached to software solutions like Exact Manager, which is like iTunes for the Exact, where you can configure all these tools on the PC and not on the device. It comes with Data Catcher, which is like a key wizard, or what was it from SpectroEye? Like export to Excel or export to third-party products. That's free software that comes along with it. Additional purchasable software, our new product for Q&A, it's ColorCert or IQC Print with a little bit more laboratory approach. Ink formulation and color quality obviously supports the Exact as well. All Bluetooth, by the way. Next to the Exact, we have created a scan adaptation, a scan functionality for the Exact. This is how it could look. It's like the like a little chassis which you can attach to your Exact, and it's easy and fast measurement for all your printing and application. This is how the chassis looks like. It's an attachable tool for scanning. It also has this little zebra cylinder in here. Similar like the ruler of the i1 Pro 2, you can also capture the movement of the Exact based on this detection cylinder, based on this zebra cylinder. So also the Exact knows exactly where it is on the sheet when measuring. So it also has a good definition where it has measured. This chassis is just attached with a little pin to the Exact. There is the release button. We have the opening here with a little ruler where you can steer the device, because when you measure, it's obviously closed. But even if it's closed, you have the little black lines left and right on your strip to really guide the device over the strip in a proper way. There are suggestions on our website what strip length and patch width and aperture size are working well together when you do your configuration. So a wide range of strips can be measured because we know exactly the position. We don't need these black separation bars, but it also doesn't harm, so the Exact will measure exactly in the middle of these patches based on the aperture size. It will, if it's 2 mm, it will only measure the 2 mm in the middle. And the color bar can be up to 112 centimeters. That's just one important information. Although you will see there at some point when you want to do it all by hand, you might want to use a metal bar where you drive it along to it. There are the resin stoppers on the back and on the front of the X-Acte, where you can put the X-Acte along of a metal bar. We've even prepared it as an additional item, but a metal ruler does the job as well. It also comes with software solution data measure, which is similar to data catcher, but in a measurement mode. So capturing data and export to Excel from a strip reading, it's easy, straightforward. This is the free software that comes along with it. Inky Control is purchasable software that is similar to IntelliTrax and EasyTrax. So where you can use your readings for your ink zone control and ink zone adjustment for the offset presses. It also connects to ColorCert and IQC Print, all Bluetooth, by the way. And that's all about our product and the M standards. Now I'm opening this session for questions, and I'll hand it over to Kletia to tell me who had some questions, and I'm happy to answer.
Thank you, Rabea, for the presentation. It was great. We give a couple of minutes to the attendees. And yes, as we said at the beginning, this session has been recorded. So tomorrow you're going to all receive an email with the dedicated link landing on our Vimeo channel, and you can review it again and again and share with colleagues. So Rabea, we have the first question.
Yeah.
What's about IntelliTrax and EasyTrax with M1?
I've just had the news from last week. I can't say any timeline, but the IntelliTrax will be amended so that M1 is available for IntelliTrax, but I don't have any time frame yet. But we are working on a solution for IntelliTrax.
Okay. So some more minutes to see if there are some more questions, and in the chat I will also give you the email address where you can be in touch with us also after the end of this webinar. Is printmarketing_eu@xrite.com. It should be now visible for all of you in the chat panel.
Yeah, I see it.
Okay. I think that's all for today, Rabea. It was a very good presentation, so it was self-explaining. And so we wish you all a very nice rest of the day, and keep in touch on our social media channels for the upcoming news and next webinars. Thanks again.
Okay.
Goodbye.
Thank you. Bye-bye.